So the change in electric potential energy per unit charge is defined as the electric potential difference, or electric potential, or voltage. So these three things mean the same thing, okay? And can be described by the following equation. Delta V is equal to delta E over Q. Now please note here, this E is not electric field strength. This E is energy. So don't mix them up, please. V is potential difference, and it's measured in volts. Our energy is always joules, and our Q is coulombs. Potential difference is a scalar quantity, so it doesn't need direction. Okay, so let's find this on our formula sheet. Make sure that you can find it. So we're under electricity and magnetism right now. Found it? Yeah. Okay. Now flip to the back side and go under constants. Okay. Under constants, and go down to one called electron volt. Electron volt. So it says electron volt 1 eV is 1.6 times 10 to the negative 6 or 19 joules. Okay? So that's here. 1 EV is equal to 1.6 times 10 to the negative 19. So you don't have to memorize that. It is on your formula sheet. So if you're being asked about EVs, you might need to convert it to joules. And if you're given joules, you might have to convert it to EVs. So what is this even talking about? Well, small amounts of energy can also be measured in electron volts. So instead of saying 1.6 times 10 to the negative 19 joules, they say, well, it's just easier, let's just call it 1 EV. It's like saying, let's just call this a mole, rather than saying 6.02 times 10 to the negative 23 every time. So it's just to make it simpler, because it happens so frequently. So, but for this formula, it needs to be in joules. So you might have to convert EV to joules on occasion, okay? So don't freak out when you're given stuff in EV, just do your conversion. So I'll show you how to do it now. So if we're to convert this many EV or electron volts to joules, we go 2.10 EV times by. Now we want to get it into joules, so we have EV on the bottom and joules on the top so that we can cancel out. Well, we know there's 1 EV per every 1.6 times 10 to the negative 19. Joules. So that will give us 3.36 times 10 to the negative 19 joules. Right. So since the electric potential is changing between a set of parallel plates based on electrostatic repulsion or attraction, the electric potential, which is delta V, is also changing. That's why it's delta, right? So I guess we could say the electric potential V is changing, so delta, even though the electric field remains uniform. So electric field, remember, is E with the arrow over top. So say we have a plate again. We have positive. We have negative. Our electric field is going this way. Now, let's say here
we have 100 volts.
That's the electric potential.
At this point, there would be 0 volts.
So, oh, and I should draw my battery in here too.
Okay, so we'll have our delta, or our electric field will stay the same, but our voltage can be different throughout the thing. So say you go down, this would be like 75 volts. Right in the middle, we have 50, etc.
So how much electric potential changes as you go closer? Almost think about it like the charged particle. If it's here and it goes down, its potential energy changes. Okay, so that's like the electric potential. Okay, so let's try. So even though the electric field between a set of parallel plates is uniform, the electric field strength can be altered by changing the separation distance of the plates or electric potential between the plates. So that's like if we would have brought our benches closer together or farther apart. Because if two charges, like you guys know, you said, okay, but our benches would be attracted to each other. So if we actually brought our benches even closer, there's even more attraction. If we brought them farther, there's less. So we could actually change the electric field strength by changing how far apart the plates are. Okay? So this formula is E with the arrow, so now it's electric field strength, not energy, is equal to delta V over D. So now find this one on your formula sheet. So this one's under electricity and magnetism as well. It has absolute value bars on it too. So how do we put this into practice?